Welcome back. In this module, we're going to revise some of the main differentiation formulas from the 2-unit HSC Mathematics course, starting with those for the main elementary functions, whose basic properties and graphs were studied in previous modules. Please reacquaint yourself with these differentiation formulas if you have forgotten any. Without too much effort, these formulas can be used together to differentiate the combination of any sum and difference of the elementary functions above. Observe the following examples. But to be rigorous, the rule that actually permits you to differentiate those functions above term by term is called the addition and subtraction rule. So for instance, the derivative of the quadratic function x squared plus x minus 5 is equal to the sum of the derivatives of each individual term. The differentiation of an elementary function that's multiplied by a constant is also quite straightforward. Observe the following examples. But again, to be rigorous, the rule that actually permits you to temporarily ignore constants before bringing them back after differentiation is called the constant multiple rule. Overall, the addition and subtraction and constant multiple rules are together known as the linearity principle, and is often expressed in one concise formula. In the previous module, we learned how to create a new function from two existing ones using the operation of multiplication. These product functions are differentiated using the product rule for differentiation. For instance, consider the product function x squared multiplied by e to the x. Letting our first function u be x squared and second function v be e to the x, the derivative is therefore the first function multiplied by the derivative of the second function plus the second function multiplied by the derivative of the first function. And this simplifies to the following. In the previous module, we also learned how to create a new function from two existing ones using the operation of division. These quotient functions are differentiated using the quotient rule for differentiation. For instance, consider the following rational function. The quotient rule then tells us the derivative is the following. Alright, it's time to pause the module and have a go at the following practice questions. And here are the answers to the practice questions.